Hello everyone, coming to you for geometry from my home today because that's where I am when I needed to record it. So here we go. We're going to talk about section 11.1 in our geometry book, page 742. Okay, 11.1, 742. So today we're talking about solid geometry, which are 3D shapes, and we're going to learn about the parts of them and kind of what they look like. So the first one we're going to talk about is just in general. I just want to talk to you about the parts of a 3D figure. We're going to be using household products today because I'm at home. So today what we're going to do is we're going to talk about the parts of it. The first one is this Kleenex box that I have. On this Kleenex box, any flat surface is considered a face. So this one has 4 faces around the outside, and also I could technically call the top a face and the bottom a face if I also, okay? So the faces are any flat surfaces that you have on your shape, 3D solid figure. Okay, then we have a vertex, which is just like on a flat shape, and it's the corner. So this one has vertexes at any place where faces come together. Okay, and then the last one that we have is called the edge, and the edge is just where 2 faces come together along this line. That would be considered an edge. Okay, so those are the parts of a 3D figure. So let's talk about the different kinds. There's a prism, which is, this is an example of a prism. Actually, it's not the one they have in the book, but this one will work. A prism is when you have 2 parallel congruent bases. In this case, mine is a square, congruent bases, okay? And then the thing that you have to watch out for these is that the bases can actually be the sides, right? Depending on if it's sitting on its side or sitting on end. Because this is almost a cube, it's a little bit of a rectangle. There actually could be a lot of bases, right? I could consider the bottom here and the top here as the bases. So it just kind of depends on what figure you're looking at. Okay, but those are the 2 parallel sides are the bases. And that's more important to be careful with if you have one like in that box on page 742, where it's a triangle as its base. Because then you have the triangle top and the triangle bottom. And those are the parallel sides. The side faces are not parallel. So in the triangle ones, it's a little bit more important to be careful of that. So it's the parallel faces, okay? A cylinder, much like a can of olives, is a round figure that has a top and a bottom that are parallel. Okay, so this is a cylinder. The bases are the circles, right? Top, bottom circles. Okay, and a curved surface connects these bases. So that's a cylinder. Okay, then we have a pyramid. Now, I don't actually have a pyramid at my house, but I have this little tree. And it's kind of like a pyramid, and it's kind of like a cone. Okay, so that's what we're gonna use. So, pyramid, cone, kind of similar, okay? This is better as a cone because it has a circle as a base. A pyramid will have a square or a rectangle or a triangle as a base, and then they'll all come together at the top and make a point, okay? So those are shown to you there, a pyramid and a cone. A cube is specifically a 3D figure that is the exact same square on every single face that you see, okay? Cubes have the exact same square everywhere, so they're perfect. 6 square faces. Okay, so then at the bottom on page 742, you can see in the blue and the green shapes, they gave you some examples. Triangular prism, rectangular prism, pentagonal prism, hexagonal prism, etc. Okay, so those are some examples. So let's look at example number 1. We're supposed to classify the figure. So it looks to me like that's a pyramid, but I have to tell me what kind. So if they don't tell you specifically that the sides are the same, they do tell me that the angles are right angles. You can see the little red things there. But if they don't tell you the sides are exactly the same, I have to assume it's a rectangle. So I would say that's a rectangular prism. I name what shape the base is. Oh, sorry, pyramid. I name what shape the base is, and then I call it a pyramid or prism. Okay, so rectangular pyramid. Then we're supposed to name the vertices, edges, and bases. You can see there they named the base is ABCD. They named all the edges, and there's quite a lot of them. CD, AB, BC, AD, etc., CE. There's just a bunch of them. And then the vertices are E, A, B, C, and D. Okay? Example 1B is the cylinder, like our olive can. Okay? A cylinder has actually no vertices, right? Because there's no points. It has no edges because there's not really a place where two faces come together. All right? But the bases are circle P and circle Q, the top and the bottom. Okay? So does anybody know what the ice cream cone would be? Oh, I just said it. It's a cone. Sorry. How about 1B? Check it out, 1B. Anybody know what that is? Check it out, 1B. Okay. It's a prism, right? It's not a pyramid. And what shape is the base? It's green. Triangle. So triangular pyramid. Prism, excuse me. Boy, I cannot do this today. Triangular prism. And you would have to name the edges, the vertices, and the bases. Okay? Example number 2 talks about a net. A net is if I take my 3D figure and I unfold all the sides and lay it down flat. And some of the problems on your assignment today, you're going to look at the net and figure out what shape that would make. Now, in this example, it says describe the 3-dimensional figure. I just want you to tell me what shape it would make. You don't need to describe it. We can see what it looks like right there. You just need to tell me what shape it would make. So I can see from example 2A that that is going to have a triangle base because there's 2 triangle shapes, okay? And if I put the 2 triangle shapes together and wrap all the rectangles around it, it would be a triangular prism, okay? And then B, does anybody have a guess what that one would be? Example 2B, the base is a square and then it has 4 sides that come to a point. So that would be a square pyramid. Okay, check it out, 2A, that would be a triangular pyramid. And check it out, 2B would be a cylinder, just so you kind of have an idea of what those look like. Okay? All right. Page 744, example number 3. A cross section would be if I took a knife and sliced this, what shape would I have if I lifted that up and I looked at what that cross section was? So example number 3A, if I sliced that pyramid, I would have the shape that the base is, right, as my cross section, because all I did was I sliced it and made it a little shorter. So that cross section would be a triangle. Now, it depends on where they cut the cross section. It doesn't always match the base. But if they cut it parallel to the base, it should be the same shape as the base. So example 3B, they cut it straight through like this, parallel to the base, it would be a circle. Check it out, 3A. Did they cut that cross section parallel to the base? They did, because the bases are on the ends this time because it's laying down on its side. So that cross section would be a hexagon. But on 3B, they did not cut it parallel to the base. They cut it up and down. So you have to think about, if I cut it up and down and I split that cone apart, what shape would I have there? And that would be a triangle this time. Okay? Example number 4 is that super cool square watermelon. I always love this problem because, and there's a picture of it on the previous page of the people. They're like cutting and tagging the square watermelon. It's crazy. I think they must just grow them in like the seed. Once they start growing, they put them in some sort of mold so that they grow that shape. I don't know. It's super cool. Anyways, how can the chef cut the watermelon to make a slice of each shape? So let's look at A. To make a square, they'd have to have it cut parallel to the base, right? Because the base of that watermelon is a square. To make a hexagon, this one's totally weird, they'd have to cut diagonal so that you can see it there in the example better than I can describe it probably. They'd have to cut through the edges, like the middle of the edges kind of diagonal to be able to get a hexagon. So on some of your problems, you're going to have to describe to me where they would have to cut the shape to get the result that they're looking for. Okay? And that's it. So there's lots of, like when you do your directions, make sure to read them completely so that if it says classify the figure, you tell me what it is, like a square pyramid or whatever it happens to be. And then you also have to name vertices, edges, and bases. So make a list of what those are. So make sure you just read the directions really well so you answer all the things that they're wanting you to make sure to answer. Okay? Okay. your math humor for today. I don't think you're ready. Question, what is the angriest part of a 3D figure? What is the angriest part of the 3D figure? And yes, you can find the answer in this section. The angriest part of a 3D figure? The cross section. Yeah, you're welcome. Have a good day.